All right, mahalo everybody for joining us. So today, this presentation will be recorded both on Zoom and will eventually go up onto our YouTube channel for Maui Invasive Species Committee. It's also live streaming to our MISC Facebook, and that'll be up immediately after the presentation for you to look at as well. So without further ado, I'm going to introduce our guest speaker today. So like his ever-changing facial hair, Brooke Mahnken's involvement with MISC has been diverse, creative, and at times a little wild. He joined the MISC Ohana in 2005, and in that time, he's worked on multiple field crews, led a project to track down and eradicate failed chameleons, built parade floats, drawn countless cartoons for MISC, and is our resident Photoshop and graphic design wizard. He now serves as MISC's GIS and data manager, as well as our Little Fire Ant coordinator, because not only is he a glutton for punishment, but he truly loves protecting Hawaii's native species. So mahalo nui, Brooke, for coming in today. And without further ado, take it away.
All right, thank you, Serena. That was lovely. I'm just going to fire up this presentation here. I need to turn. Okay, so as Serena said, I'm Brooke, and this presentation is an update on the little fire ant situation on Maui. And so I'm going to show you what's up with LFA, why they're bad, why we don't like them. I'll go over that briefly, and then how's things on Maui and how we do things on Maui. And then we'll talk story about helicopters at the end, because that's kind of an exciting aspect to the work. So in Hawaii, we have over 60 ant species. All of them are introduced. So every time you see an ant in Hawaii, it is not a native ant. We have more than one type of fire ant. That's important because we spend a lot of time tracking down reports of fire ant stings. And we are interested in little fire ants. That is Wasmannia auropunctata. We also have tropical fire ants, Solenopsis geminata. And these are the ones, these have been around for a long time, often encountered at beach parks and ballparks, etc. They like a drier environment than the little fire ants. And they come out of a little mound in the ground, and oftentimes they will sting your feet, or if you're sitting on the ground, having a picnic, or at a soccer game, etc. We also have, there are several stinging ant species that would be terrible if they were introduced to Hawaii. And one that is well known is the red imported fire ant. And this ant is in Texas and spread throughout the South United States. We are on the lookout for those ants, but we do not have those in the state of Hawaii. If they were to get here, of course, we would mount appropriate response immediately. We don't want those ants. They're also terrible. They are one of a list of several ants that we do not want in Hawaii, and we are on the lookout for. So this is what a little fire ant looks like, blown up very close. They are tiny, tiny little ants. These things are about as long as a pencil lead is wide, or a nickel is thick. Very tiny ants. So you could not see the detail that I'm showing here with your naked eye. It requires a microscope. And as I will talk about later, we use a microscope to identify these ants. They have many common names. In Hawaii, they're known as little fire ant, which is confusing because there are so many different types of fire ants. In Australia, they call them electric ants, and we already missed the boat on that one. Too bad we don't call them electric ants. But little fire ant is what they're commonly known as here in Hawaii. They are considered one of the world's worst invaders. They are arboreal, meaning that they live up in trees as well as the ground, and they form super colonies. Oftentimes, ants of the same species will have two nests, and they might fight each other. But in the situation of invasive pests, invasive ants, particularly this species, they pay allegiance to any queen, they work together, and they form massive, sprawling super colonies. And they sting, of course. This is not like tropical fire ant sting, which is a larger, more painful sting, but what happens with the little fire ants is that they rain out of trees, they cover their victims, and then they all start stinging at the same time. And you develop these rashes that are itchy and persistent, sometimes for weeks into months. They are devastating to the environment, agriculture, and quality of life. They are a total economic disaster, and we want to keep them out of Maui and any other places in Hawaii that they are not currently. So, as I said, they sting, and it sucks. It is super lame, and you can see a rash right there on some people that have been stung by little fire ants. They ranch pest insects, and so they increase the number of pest insects on agriculture and orchard trees, and they also make it nearly impossible to harvest those fruits. And as you're picking the fruits out of trees, etc., it shakes the branch. These ants, they fall very easily, cover the workers, and in some places, like on the Big Island, where it's densely infested, sometimes these farms have a hard time finding people to do the work, which is lame. And they sting pets' eyes, and this is really tugs at the heartstrings. But they can, repeated stings can cause blindness in pets or domestic animals, especially animals that can't get away from them. The ants are often attracted to pet food, and so the pets are, putting their nose right into that food and getting ants on their faces, and it causes blindness. You can see the clouding in the eyes of these animals in this image. That's super lame. So they really put the F in little fire ants, if you will. Where did they originate? They came from South America, the Amazon region. You can see in this is a screenshot from a scientific paper about the spread of little fire ants, and the green area is where their native range is. And you can see how they have spread out across the world. They first arrived in Florida in 1924, and then in Hawaii from Florida in 1999, they were first detected on the Big Islands. So this map is a little outdated, but from 10 years ago, and this is what the Big Island looked like, the sort of sprawling large infestation on the Big Island. It's totally out of the bag over there. There's no eradicating little fire ants at this stage. This is very different from the situation on Maui, where we have discrete populations that we're working on. This is probably much more widespread today. And if you live in the Hilo area on the Big Island, you probably are treating your property to keep little fire ants off of it. And you'll be doing this forever, perpetuity, just to carve out your little safe zone in the sea of fire ants. This is the situation that we are trying to avoid on Maui. Unfortunately for the Big Island, but fortunately for Maui, we learned from their trials and tribulations with little fire ants. So today on Maui, this is a map, a graph showing a timeline of infestations or incursions on Maui. And so when I say incursion, I mean ants that have been detected beyond the port. So we do a lot of commerce with the Big Island, and they ship containers over, and the Department of Ag surveys these containers before letting them out on Maui, and they frequently intercept little fire ants at the ports. This timeline is showing when those are missed and little fire ants are found somewhere on Maui. That's when Maui Invasive Species Committee comes into play. So some of these incursions were very discrete situations where, for example, a pallet of shingles was brought here from the Big Island and it was infested with little fire ants. The person was aware and called the right people, Department of Ag, Maui Invasive Species Committee, and Hawaii Ant Lab, and it was immediately treated, and those little fire ants were wiped out, and that was the last we saw of them. We've gone back and surveyed the location that they were treated at and never found ants since then. So that was an incursion. In other situations, they were naturalized, where they were left and allowed to reproduce, and the population grew in size, and those became infestations that we've worked on for years and years. So you can see 2009 was the first detection of little fire ants on the island of Maui. It's quiet for several years, and then we began to see an uptick in new infestations on the island of Maui, including 2 new infestations last year. This here is a map of those 17 incursions to Maui, and I have them this color coded. Hopefully you can see the color difference between the yellow and the green here, but currently we have 3 active sites, and those are sites that are currently under some sort of treatment or full treatment. Those are generally new, but 2 of these sites actually we've had for a while, and they're proving to be more difficult to get rid of. And one of them is a very large one in East Maui. You can see it there, and I'll talk about that later. That's the Nihiku infestation. It's the largest infestation here on Maui. 5 of these sites I'm calling transitioning, meaning that we have done a full regimen of treatment on these sites, and we've gone back and done a survey, and the infestation is greatly shrunk down. From there, we will go on to treat those small spots. We call that hotspot treatment. And eventually they will disappear, and we won't be able to detect ants anymore, in which case it will become a monitoring phase. It will fall into the monitoring phase, meaning that we're going to go back for several years to survey over and over again to make sure that their ants are truly gone and don't come back. We've learned this the hard way. After 5 years of surveying like that, then we'll toss around the E word, eradicated. Okay, we can be confident after 5 years of those surveys, not finding any ants, then we'll call that site eradicated. You can see here I have 2 sites that are considered eradicated because they've passed that 5-year threshold. We do not go back to those areas anymore. We're calling those done. Now, 4 of these sites, sorry about that. 4 of those sites have little lightning bolts on there. Those were what I'm calling incursions, where the material showed up, oftentimes a trace back or trace forward from the Department of Agriculture, meaning that they detected ants at a port somewhere else maybe, and they went back and said, well, where did this come from? It came from this place on the Big Island. They also shipped it to these other places, one on Kauai, one on Maui, and they go to those locations where it was distributed, and they find, yes, indeed, there's little fire ants, or the shingle example I gave earlier. Those are incursions where the ants were quickly treated and never seen again, so they didn't naturalize and become an infestation. I'm not including those incursions on this graph here, but this is the size of the area that we treat when we go to control these sites. Not all infestations are equal. As you can see, the Nihiku one on the left-hand side with the question mark, that is at least 45 acres. It's actually much larger than that, the area that we're treating, and I'll talk about that in detail at the end of this presentation. I have these color-coded the same way I had on the map, yellow meaning transitioning, red meaning active, and blue is a monitoring. How do LFA spread? Well, they spread slowly by themselves. Most ant species, they establish a new population when a virgin queen flies away. Ants have wings. Usually you see them without wings, but they can fly a far distance and establish a new colony far away, and that's bad. Fortunately for us here on Maui, little fire ants do not operate in that manner. They simply crawl away, and being so small, they don't crawl very far. So we call that budding, and the population kind of buds off and expands slowly. So that is to our advantage, at least. It must be a queen to establish a new population. Workers, the ants that you typically experience or come across in the environment, those are sterile. They do not start new colonies. So if you were to take a bunch of workers by accident with you somewhere, you are not going to be establishing a new colony. It needs to be a queen or a nest moved. The biggest risks to movement of little fire ants are people in particular, because people can pack up a bunch of stuff in the back of their truck and drive to a new location and unpack it and establish a new colony if they had a nest in that material. And waterways here on Maui. So if there is an infestation on a stream, which in many situations there are, that water can wash those ants downstream. When that happens, it's important to keep in mind that the queen must survive that. And then it's difficult to reestablish in those events where they're washed downstream, because they also need workers to help them reestablish. The queen otherwise has to go forage for her own food and put herself in danger. And so we see fewer of these instances than one might expect. How are little fire ants spread by people? So I created this graphic just to give you an idea. This is not based on science or numbers, but this is a sort of general idea of how risky certain behaviors are. So if you walk or drive through an infested area, you're not going to be moving ants generally to another place. Even if you picnic there, if you picnic there for several days and you allowed ants to creep into your picnic stuff or whatever, and then you moved, that would be a higher risk. But if you're just sitting down, you're generally not picking up queens and nests. If you use garden equipment, if it gets materials, particularly branches and foliage stuck in it that may have a nest lodged in there, then that's a little bit of a higher risk. But really the riskiest behaviors are moving idle materials. So things that have been sitting on your property for a long time, like a derelict vehicle. There are many in Hawaii. If there's like an old truck that's been parked under a tree for months and months and it gets towed away, that is likely to have nests and things established in it that it can move. Or if you take potted plants, the sort of things that little fire ants like to live in, and you move those types of materials to new sites, that's very risky. So here I'm going to talk about how we do the work that we do. First thing you got to do is you got to survey so that you know what the population looks like before you do anything else. And to do that, little fire ants really like peanut butter. Ants, depending on the species you are surveying for, they may like jelly better than they like peanut butter. Some like sweet baits, others like protein baits. Some of them like Spam and peanut butter put into a blender. That's really gross. But the peanut butter is perfect for little fire ant survey. You can put it on a little stick. We use these little plastic vials as shown here. Put that out, leave it for about half an hour, 45 minutes to an hour or longer even. You come back and it should usually be filled with little fire ants if you're in an infested area. So they will forage out for food, and what we use as our estimate is about 5 meters. So that's like 15 feet from the nest. They will travel out to forage for food. And so when you put down one of these little vials, you are surveying an area that is 15 feet in every direction, theoretically. Once we leave those out for a half hour, we come back, put a cap on them, write a number on that cap, take a GPS point with that number, take that bag of vials into a lab and look under a microscope at each vial. Because little fire ants are so small, there are other little orange ants that you can't tell apart with your naked eye. So we need to go through every single sample with a microscope to positively, confidently identify little fire ants. Here is an example of what this might look like in the field. In the center of this image, there's a little yellow dot. That's where you put your sample down, your peanut butter vial, and you're sampling an area roughly 5 meters in all directions. Meaning that if there were nests within that 5 meter area, you would likely detect them. Each one of those nests has its own foraging range of 5 meters in all directions. So when we estimate an infested area, we say 10 meters because that's likely to include all of the nests in all directions. It's a liberal estimation of what the area infested might be. When we do our treatments, we treat out 20 meters from every positive ID. This is to make sure that we're putting our treatment out in an area well beyond where we've detected them, just to make sure our process is not perfect. So just to make sure that if we miss something out there, like here, and we missed that nest, we are putting out our baits to treat the ants that we might not have seen. Now here I've overlaid a grid onto this. This is something that we would do once we've figured out what the treatment area is going to be. Going forward, we're going to have to survey it over and over again. And so we can use grids like this, or even tighter grids, to evenly space our survey samples out. We'll put those things onto a GPS unit that we can see as we're out there doing the work live, so that we make sure that we get a thorough and complete coverage of our treatment areas. How do we do the treatment? Well, we use a number of different products, from insect growth regulators, which is birth control, more or less, and toxic baits. We put bait out. Ants are social insects, and so they go out and they work together to gather up food, and they bring it back and they feed the queen, they feed each other. And so bait is the best way to do it. There's other ways to kill insects, like everybody's familiar with Raid or something. You spray it directly onto the insects. That will kill the insects, but if you do that with ants, you're just killing the workers. You're really doing nothing at all. The queen will just produce new workers to replace the ones you've killed, and you'll be going around in circles forever. So what we need to do is we need to kill the queen. We need to kill all the queens. As I said earlier, there's a super colony in the case of little fire ants, and there are thousands upon millions of queens out there. And so what we do is we need to evenly distribute the bait throughout the entire infested area, so that all those workers go out, gather it up, and bring it back to each of the respective queens. We do this every 6 weeks for a year, and then go back and do a very comprehensive survey to determine how effective that treatment was. Here is a graph that shows relative toxicities of some different products you might be familiar with, including at the bottom of this graph, caffeine and ibuprofen, both more toxic than any of the materials that we use, the baits that we use. None of the things that we use in this project are restricted use pesticides, meaning that you don't have to have a license to use it. Anybody can get these off of the shelf. They're very tightly regulated federally, and we use them very strictly to their labels. In the case of this methoprene at the very top, this is the insect growth regulator. It's not even toxic to the ants themselves. It tricks the queen into thinking she's too young to lay eggs. Essentially, she quits laying eggs. Workers have a finite lifespan. They will start to die off after 3 or 4 months, and they're not being replaced by the queen. And eventually the queens are left without their workers and become vulnerable and will die off shorter than their predicted lifespan of around 2 years. When we go out in the field, this is the process we use to make sure that we are getting that thorough coverage I mentioned. So you can see we take a map, we reproduce that map onto a GPS, and we have that in a harness right there on our chest. And so we can see real time that we are covering very thoroughly the entire infested area. This is a graphic showing what our control strategy is. I mentioned that we treat every 6 weeks. We start with the insect growth regulator, and we feed that to the ants for 6 months. That will ensure that it's very likely all the queens are now on birth control. We then at that time switch over to toxic treatments. And the toxic treatments combined with the insect growth regulator is very effective. Oftentimes, if you use a toxic treatment alone, the ants will respond, the queens will kick it up into high gear and replace all those missing workers. And so they'll actually increase production of new workers to in response to a major die-off from toxic bait. If you've been feeding them the birth control beforehand, and then you switch to the toxic bait, then you can expect to see a much more extreme crash of the population. So sort of 1-2 punch, that combination. At the end of the insect growth regulator and the toxic treatments, 1 year, we go back and we do the survey. If we find any ants at that time, that's a hot spot. The infestation has greatly reduced down, and then we treat that hot spot over and over again until we detect 0 ants. At that time, we go into the monitoring phase. And as I mentioned earlier, we take 5 years to monitor. And it's several surveys. In the first year, we do 4 surveys, and then we kind of taper off to 3 surveys, 2, 1, and then we close out that 5-year monitoring phase with 2 surveys. At that time, if there are still no ants, we consider that infestation eradicated. So here I'm going to show you what it looks like in practice to do this. This is a real infestation here on Maui. And so the little red dots are where we found little fire ants, and the little blue dots are where we did not find them. So we zoom into the red dots. We're not so interested in the blue ones. This would be the area that is infested, the 10-meter buffer. This would be our treatment zone, the 20-meter buffer. So we would go in with our GPS unit that has that map on there, and we would do the treatments. You can see this first treatment here. We actually didn't have this map ready, and there were several parts of this infested area that were totally missed. But subsequent treatments, we figured that out. Of course, not every single part of this is been painted in with the yellow. That's our treatment tracks. That's the GPS track as we're out there. There are gaps, and those are these big houses or the beach. We can't treat below the water line. And we'll do this treatment over and over again. And halfway through, we do a survey to see how things are going. And that grid there helped us to evenly space our samples out. And you see right here in this image, there was only 1 detection, 1 sample detected little fire ants. So things are on track. We continue the rest of our treatments. We come in at the end of the year, and you can see this grid that I've put up is a much tighter, smaller grid. So we put out a lot more samples. And in this situation, in the same location, we found some, but we also found some up near the top. And there they are. And so this is where we would go into a hot spot treatment phase, where the infestation is now greatly reduced. We're only finding ants in these locations. So we go back in here, and we will continue our treatment on those areas. We did 3 treatments there. We go back in. You can see this is a sort of modified grid that I've put up here. I have tighter spacing for the samples in the areas where we most recently found them, and a looser spacing elsewhere. And well, lo and behold, in those areas we just treated, we didn't find ants, but we found another one elsewhere. And this is often how the treatments go for several years until they're totally wiped out. So I just show you here, this is an illustration continuing on. Here, this is an infestation. This was the original infestation on Maui and from 2009 at Waihee. And this is what it looked like in 2016. And following what I just showed you, that methodology, in 2019, this is what it looked like. There was no more little fire ants. And in fact, we are going on 3.5+ years where we have not found any little fire ants there. So this shows you how it works. This is an example of successful treatment of little fire ants at a naturalized site here on Maui. So reviewing back to this map, now that you know what all this means, you can see with 3 active sites out of 17 instances, things are going pretty well for Maui. We've got little fire ants on the run for the most part. We've got a couple of problems that we're dealing with, but it's working, and that's great news for Maui. One thing that is a question is this big infestation in Nahiku. Now, this is much larger and different infestation than any of the other sites. It's in very wet, jungly area that has all sorts of extreme terrain and vegetation. And I'll show you what that site looks like here. We can, a little animation, and you can see it's a long, skinny infestation, and that's precisely because it was introduced Mauka and right on a stream, and that stream carried that infestation all the way to the ocean long before it was ever detected. And that's how it got to be so big. It's also the perfect environment for little fire ants. They are from South America, the Amazon, so this part of Maui is ideal. This is what it looks like, and you can see our surveys have a lot of gaps here. Well, why is that? Here I've turned it into the 20-meter buffer I showed earlier, and in this situation, it was probably introduced, like I said, up Mauka, and the stream washed it down. And the gaps are because in some of these areas is very dense how bush, which if you're familiar with, it's like climbing through a jungle gym. We simply cannot walk into those areas and conduct the surveys that we need to do. So some assumptions have to be made about this infestation. And in addition, we need a helicopter to treat it because we can't treat in there. Not only can we not survey in there, but we can't walk through there with our backpack sprayers and the equipment that we need. And it's so massive in acreage that we need to use a helicopter. So I'm going to talk about that. The one thing about the helicopter is when we fly above, the product that we use is going to end up in those waterways. There's no way to avoid that. And so we had to pick something that could go in those waterways. Now, before I get to that, these are several different options of the area that we could treat. We need to treat the infestation beyond where we know it is, and even further than that, because there are so many unknowns. We need to pick a wide swath around it where we know there aren't ants and treat everything inside to make sure that we're getting it because of all of those knowledge gaps from the extreme terrain and the vegetation. Now this isn't the first time ants have been treated with helicopters. There's existing platforms. In the image on the right, there's hoppers on that helicopter, and those are for granules, and the granules generally are toxic, and we cannot use a toxic bait. What we have to use is that insect growth regulator, the one that is very low impact. And so that was out. A boom spray was an option. What we do is we mix this bait into a gel, and that gel bait is important because when we do our treatments, since they live in those trees, we have to squirt that gel bait up into the trees so it sticks up there so that the ants can get to it. And so when we're treating with a helicopter, that gel bait sticks in the tops of those trees, but we also need it to drip all the way to the ground. So a boom spray was an option that we considered. And I'll talk about that in 1 second, but this is the insect growth regulator. The S-methoprene is what it's called. It works as a birth control. It's a very low environmental impact, especially on non-target impacts. Mainly those non-target impacts are going to be other ant species. And like I said in the beginning, no ants are native to Hawaii. If it goes in the waterways, some of the other things to consider are the aquatic organisms, the fish, some of the aquatic arthropods. But the way that we're putting it out, fortunately, is in a low dosage. And I have been there myself since the treatment began several times, and the streams are filled with fish and arthropods, so it does not appear to be having that impact. This stuff is used widely in the US to control mosquitoes in places like Florida, where mosquitoes are a real problem, especially with malaria and other diseases. They put this into aquifers and lakes, et cetera, to keep mosquitoes down, and water that's destined eventually to be drinking water And even the World Health Organization recommends if you live in a place where you store your water in like a clay pot and malaria is an issue, they recommend you put this in the water to keep mosquitoes down. So very low impact, and that's what we're using from the helicopter. Again, here's this graph I talked about earlier about the toxicity. I'm going to skip through here. This is just above water essentially for its toxicity, the S-methoprene. So our gel bait that we use is mostly water, then vegetable oil. We put beef liver powder. Earlier I talked about surveying with peanut butter. You can use peanut butter. In the case of this, the ants actually like beef liver better, and so it's believed to be more attractive. So we use beef liver powder. We use our active ingredient, which is the insect growth regulator, and then xanthan gum, which is a thickening agent used in all sorts of things from ice cream to toothpaste, shampoo, etc. It's a food grade thickening agent. So it makes this goopy sort of gel. It's consistency of pancake batter that will stick to the leaves and the trees and hopefully drip down to the ground in some of these cases with the helicopter. Before, of course, we did any of this, we had to go through several regulations. In the meantime, we treated the areas where people live in this infested area so that they weren't moving the ants because we weren't treating most of the rest of the infestation. We had to get a special local needs permit to use the product in this area. The Department of Fish and Wildlife came in and surveyed for threatened and endangered species in the area and did not detect any that they were worried about, particularly a native damselfly. And we had to figure out a way to deliver this bait from a helicopter because there are not necessarily out-of-the-box systems that you can hook up to a helicopter to use this gel bait. This gel bait was developed by the Hawaii Ant Lab on the Big Island specifically to battle little fire ants in Hawaii. And there's, like I said, there's nothing that you can hook up to a helicopter. So I mentioned earlier about testing with the boom sprayer. It so happens that Windward Aviation, who we contract to do the helicopter work, has a boom sprayer. So we went down there with bucket loads of this stuff and went to run it through their boom spray. But what we came to learn is with the boom spray, there is a rotor wash and the helicopter needs to be traveling at like 45 miles an hour, or that boom spray will come, the stuff that comes out will be brought back up into the helicopter because of the rotor wash. And what we're trying to do is a very specific treatment of a specific area, and we need to be traveling slower, not to mention we can't get the bait to come out fast enough to travel at that speed. So we had to scrap the idea of a boom spray. Here's another day that we went down there and we're trying to calibrate how much of this stuff comes out. We need to know exactly how quickly, how much stuff, the volume of it comes out so that we can figure out how much we're putting on the ground because we need to hit a very specific threshold. So fortunately for MISC, we have a lot of experience with aerial ops. I don't know if you just saw Mike Ade's presentation, but he was talking about some of our plant targets, and we have used for years these boom sprayers, which is a long line and a spray ball you can see there in that image. At the bottom, we lower that down on top of some of our target species in extremely remote areas, and we can apply very surgically a couple of doses of our herbicide to those plants. Well, what we decided to do was to adapt that for our gel bait. Now, it's very different trying to push a liquid with a pump through a system like this than a gel. And, you know, we tried with our original setup and those pumps were too weak. So we had to revamp and redevelop this system with a bigger pump, larger lines to push more of this product through. And it took a while. Here we're testing out that new pump. And as you'll see here, it was much more powerful than what we were using. And we ended up settling on this model to push our bait. You can see quite a bit of liquid going through there and coming out with quite a bit of force. Then our next step was to build that into the spray rig. And we needed to distribute that bait, not just from one nozzle, but from 5 nozzles in all different directions. So that's what that looked like. Okay. And then we needed to test it with the helicopter. And so we hooked it up, positioned those nozzles into a modified spray ball in all directions. And this should be a video there. There we go. And because this is positioned down below the helicopter, we don't have to worry about the rotor wash bringing that bait back into the helicopter. And we can travel at the speed that we need to hit our threshold. Now, to figure out what that application rate was, we needed to measure how much was coming out. And so here, this was a pretty wild day. We had to lower that spray ball down into a garbage can and spray it for, this is inactive bait. It doesn't have the active ingredient. We'll spray it for like 10 seconds. And then these guys on the ground, this is Adam Knox, our operations manager, had to take that bucket as we held hover and go weigh it, bring it back. And we do that again over and over again so that we could figure out, calculate what the flow rate was so that we knew what our ground speed would have to be as we're flying in the helicopter. And I don't know if you could tell, but this poor guy, Adam, got his face covered with gel bait, this vegetable oil stuff. It's pretty gross. Once we had that figured out, we also needed to know how far our bait was spraying. We had to figure out what the spray pattern was. And so again, we held hover and we sprayed here, and we had guys on the ground come out and they mapped out that area, that the footprint of the spray pattern. And this, once we'd collected this information, we were able to do the math. So the area that we were treating, 150 acres in Nahiku, that's the treatment zone that we settled on, with a flow rate of 13,500 grams per minute. That would, and the width of that pattern allowed us to figure out what our speed had to be in the air to get the perfect application on the ground. And this is what it looks like, how we figured that out. And it's essentially, in the end, 10.5 miles an hour is about the speed that we needed to fly to get the proper application of the area. This is all had to be worked out before we could begin any treatment on the infested area. And so in the end, this is the zone that we ended up choosing to treat. Here is what it looks like in the helicopter on the GPS unit. As we're flying along, we enter the zone and we start spraying. You take a point, and as you exit, take another point. And that way we can go back and clip up our GPS tracks to show where we were treating. So the passenger is doing this, is managing this data in the helicopter as the pilot is flying along in communication. And when that is all finished, this is what that data looks like. You can see the green dots are where we started spraying and the red dots are where we stopped spraying. And so when you process that data, you can see the yellow lines are where we were treating and the blue lines are where we weren't. And then you end up with, it's actually 3-dimensional data, very interesting, but you can make determinations about how thorough your treatment was and calculations over time of how many times specific areas have been treated, et cetera. Anyways, I don't have the end result of this. We're still working on this. This treatment has been going on for over a year. There have been 13 treatments to date, or 12 treatments to date. And we're going to do a couple more before we need to do a massive survey of the area. We're going to get all staff out, you know, as best we can with COVID restrictions to survey the whole area. And at that point in time, we'll know how things are going. And hopefully what we will see, like in our other infestations, that it's shrinking, and be able to target more specific areas going forward. Like I said, I don't have those results yet, but some preliminary surveys of the area do indicate that the ants are disappearing where we have done those surveys. We just need to do a very comprehensive one to be able to get a snapshot of the entire infestation at one time. So I hope you enjoyed that very rambling presentation about little fire ants on Maui with some specifics on aerial treatment. Kind of difficult to give a presentation like this when you have no idea who's watching or if anybody's listening. I think maybe I'm just looking into a camera at myself talking, but thanks to everyone. Hawaii Ant Lab, Hawaii Department of Agriculture, and the Hawaii Invasive Species Council. All this would not be possible without them. And of course, our crew in the County of Maui. Sorry about the dog.
Thank you, Brooke. That was super interesting, and you tell a great story with your visuals. I know I appreciate that. We want to make sure that we have an opportunity for people to ask you questions, either in the comments or question and answer box on the Zoom or on Facebook. So I do see that there already was one question, well, or more so a comment from Fern Duval. He said, he asked if this presentation can be sent to Mike, I'm not going to say his name correctly, Opker North, if somebody, do you know who that is, Brooke? At the NTBG at Kahanu Gardens. They would like to see if NTBG Kahanu Gardens would entertain assisting MISC in June for the Nahiku treatments.
Yeah, and so these are recorded, right? So we can definitely get that to Mike.
Okay, and I'll copy that name for you too. And then there's and you guys, everybody participating, this is a really great opportunity to not only ask about the little fire ant, how the MISC is, how MISC and their partners are treating for little fire ant, but I suspect that Brooke is also pretty knowledgeable about other ants that you might find around. Sorry, I don't want to open it up too much for you there, but we've got a comment here. Asking if you could talk a little bit about Kalpakalua. Why am I not saying that correctly? Sorry. Incursion, infestation. How large is it? What are the chances for eradication?
Sorry, I was muted because my little dog is barking here, but that infestation, the treatment area is 5.4 acres, and it's on partly on a farm, which is alarming. But we're working with them, and they're not moving any of that material out of the farm. Department of Ag, James Fleming has done some trace forward and trace back, meaning interviewing those people to see if those products at the farm have been going other places, and that would be tracing forward. And then tracing back would be trying to determine where the infestation came from. Right now, we're not really sure where it came from. It's often very difficult to figure out how these things got there. But the other portion of the infested area there is residential, and fortunately, it's very easy to treat because of that. You know, it's not a jungle. It's a well-maintained, mowed, nice area to walk through. So that really makes treatment a lot easier and also more effective because it's easier. And so the one thing I worry about with that site is there's some very large trees, and we can only shoot our bait from the ground up about 20 feet or so. And so if that tree is much higher than 20 feet, the ants can come down to get the bait. But if they have everything they need up there in the top of that tree, they may not come down to our bait to get it. And so we can do the treatment and get through the whole thing while those ants persist at the tops of those trees. But in many situations, I think, depending on the tree species, those ants, some trees, they don't seem to like at all. Other trees, they really do like. For example, banana trees have a lot of habitat and food for them. And other trees like ironwoods or allelopathic trees that put out like toxins into the environment, like eucalyptus trees, they don't seem to like as much, and trees without pest insects. So anyways, long story short, that infestation is well underway. Things are going good, and I think that that one will be cleared up in regular time.
Thank you, Brooke. Does anybody else have any questions, whether on Facebook or in here? And Fern shared with you the contact information for the NTBG person, and I copied it down. I can share it with you too. But this is a great opportunity to learn from somebody who has definitely been around, and as you could tell, is very well versed in all things little fire ant on Maui. See. Got some mahalos coming into. Alex Clapp, thank you for your answering his question about Ka'apakalua.
Just wanted to remind you and share, if Brooke hasn't already, or just to say it again, you know, we need our community support in identifying little fire ant populations. I believe it's 11 out of the 17 infestations were actually from community reports. So really, really important to, you know, just get involved and put that into your practices, and share with your friends to do it as well. And a fun way to start learning how to test for little fire ants, we have a virtual scavenger hunt for the month of Hawaii Invasive Species Awareness Month. And one of the activities is testing for little fire ants. And if you do all 3 of the activities in the scavenger hunt, you get a prize, and then you get entered into a raffle to win one of 3 ohia trees that we have. So fun way to learn how to practice these really important methods of preventing invasive species on your property and from spreading, as well as getting some cool prizes. So that's
yes, Serena, I would just like to reiterate what you're saying exactly. Is most of our infestations have been found because the public called in reported stinging ants. And if you care about this and you want to help, report stinging ants and go tell your friend to report stinging ants. That would be a huge help for us, because that's really the biggest tool in discovering new infestations on Maui.
Absolutely. And this is something that I really learned working with MISC. You know, growing up in Hawaii, you're on the playground or you're in the forest and you get bit by ants and you kind of don't really think anything of it. You're like, ah, okay. And sometimes you get welts. And I've never really thought about it until getting into this field, where like, wow, okay, this could be something really harmful to our environment. So report. And I'll put in the contact information to do so, that you can share and spread with your friends. Yeah, thank you everybody for joining us. Thank you, Brooke, and thank you for bringing in your co-host as well, Miss Peach. This is what we're really here for. We're here for Peach. No, but yeah, mahalo nui everybody for joining us. We look forward to seeing you soon. Have a great day.